Actually, if we consider like young, for me, the young people are around 35 age. For other people like Opurbo, he can consider 25 years old people are young. For me, 35 years people are also young. Okay, so uh, depend upon the nature of the person or this, we can assure whether young people belongs to the set or not. For this one, I'm showing one PPT which is not made by me, but it is already there in the website. Okay, so wait a minute, I'll show it and I'll discuss it. Okay, wait a minute for that one. And it will be easy for you to understand what is fuzzy and why we have to know the fuzzy set. I'll share my screen. Wait. Wait a minute. Whether it is visible?
Yes, ma'am.
Whether the screen is visible?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Wait a minute. Wait. It is visible?
Yes, ma'am.
Yes, ma'am.
I'm showing here. Here, first is the introduction, that is fuzzy. Already I have told you, fuzzy means vagueness. Okay, and in 1965, Zadeh introduced the concept, and classical set theory is belongs to 0 or 1. Either the element is belong to the set or not. But fuzzy means in between 0 and 1. Okay, it can be 0, it can be 1, or it can be in between 0 and 1. Okay, like here 25 is young, and for other 35 is also young. Okay, now look at here, I'm showing here one example. That is the difference between classical set theory and fuzzy set theory. Classes are object with sharp boundaries. That means either it is 0 or it is 1. But in fuzzy, it can be within 0 and 1. Actually, whenever we define fuzzy set theory, we have to define a membership function. And that membership function is assigned from x to the interval, closed interval 0, 1. Okay, x means whatever you want to like. If you consider the cars. Okay, X contains say 5 cars. The capital X contains 5 cars. Okay, and we want to find out the most beautiful car or most expensive car. Okay, now 5 cars are there. For me, say above 6 lakh is most expensive. Okay, above 6 lakh is most expensive. So for the here we consider first 5 cars. For one car, I have given membership value as 1, which is most expensive. And other than that car, I'm giving the car which is 5 lakh 5,000. I'm giving the membership value is zero point 0.9, and which is 4 lakh. I'm giving the membership value as 0 0.8. In this way, actually, if for classical set theory, if any car is less than 6 lakh, then the membership value of that car is 0 for normal set theory, because this car does not belongs to the expensive cars category. Do you understand that point? Whenever um, whenever we consider expensive cars, whenever we consider expensive cars, my point is if any car is more than 6 lakh, we can consider it as an expensive car. Okay, now if we consider the normal set theory, then if the price of any car is 5 lakh 90,000, whether this car belongs to the set, whether this car belongs to that set, because we consider the set as expensive car which is more than 6 lakh. So 5 lakh 90,000, the price of the car which is 5 lakh 90,000, whether this car is included that set? No, this car is not included. But if we consider the fuzzy set, this car is also included in the fuzzy set by getting some membership value, because this is closely to the expensive one, isn't it? 5 lakh 90,000 is closely to the expensive one, that which is 6 lakh. So that car also included in the fuzzy set theory. Do you understand that part? And say 5 lakh 90,000 car, I'll give that membership value as 0 0.8, and which is 4 lakh, I can give the membership value as 0 0.4. That depends upon on me, individual, that what kind of membership value you want to give that car. That's why that is the difference between classical set theory and fuzzy set theory. Like in these days, like winter season, uh, always we use the term as hot, cold. Yes or no? Hot, cold are
Yes.
there.
Yes.
Hot is extreme. Hot is extreme, and cold is also the extreme in the negative sense. So if we give cold as 0 and hot is 1, if I am telling you warm, whether this warm term belong to normal set theory?
Yes, ma'am.
If we consider two terms first one is hot, another one is cold. Okay, for cold means we know that the value is 0. Hot means extreme, that means 1. Okay, now if the term is like warm, whether warm term is belonging to the normal set theory, because warm is lying between hot and cold.
Ye-
No, it's not in
Yes
the
or no?
normal set theory.
No, ma'am. No, ma'am.
I think
No,
it,
ma'am.
Not.
Worldly.
It is.
No.
It is not. No, it is not included in the normal set theory because it is not cold. It is not cold. These are not extremes. These are in between hot and cold. The warm term, isn't it? So, but in fuzzy set theory, we can include the term warm also. Is it clear?
Yes, ma'am.
So, that's why that means the fuzzy set is the extension of normal set theory.
Ma'am, please repeat.
Okay. Actually, whenever we consider hot and cold, hot means extreme, maximum, and cold means minimum. So, if we consider these two terms in terms of set theory, we can give cold as 0. Cold means 0 and hot means 1. So, these two terms are, we can include it in the set theory. But in between hot and cold, one term is there that is warm. Whether we can conclude warm in the normal set theory, Sagorika, whether we can include it in the normal set theory,
Yes, ma'am. Punna
whether we can include warm in the normal set theory.
Yes, ma'am. I said.
No, we can't include warm in the set theory because warm is not 0, not 1. In between 0 and 1. That's why in normal set theory we can't include warm term. Like here, I'm showing here one page. First one is water colorless? The crisp set, that means our normal set theory. Either yes or no. Yes means 1 or no. If it is colorless, if the answer is yes, then 1. If the answer is no, then we go for 0. Is it okay?
What is it going on?
Yes, yes,
Ma'am,
yes.
what's happening?
Shubham, I can't
Yes, ma'am.
understand your
Yes, ma'am.
word.
Actually, I'm the new student.
New? New?
I am the new student, ma'am.
Okay. So,
So I want to know that what's going on.
okay. Actually, today I am giving the lecture on set theory and foundation of mathematics. Okay. Already we know the preliminary thing of set. That's why I am right now I'm going to talk about the fuzzy set theory, which is the extension of set theory. Is it okay, Shubham?
Okay, ma'am. Okay.
Okay. First one is water colorless? If your answer is yes, then you can give 1. If your answer is no, you can give 0. Okay. Now, next one is Ram honest? So, it will depend upon the individuality. If 5 members are there, okay, here 35 members are there. For every 35 members, Ram is honest, it will depend. If for me, if Ram is extremely honest, I'll give him 1. Okay? And that
Okay.
1 means the membership function. And membership function is that one which we will give that Ram's honesty. Okay? For me, if Ram is extremely honest, then I'll give 1. For any other people, if Ram is not extremely honest, very honest, they can give 0.8. And for other person, Ram is not that much of honest. He honest, but not that much. So they can give 0.4. And for some people, he is not at all honest. So they can give 0 also. So it depends upon the individuality. What membership value we want to give for anything. Is it clear?
Yes, ma'am.
Like I've,
Yes, ma'am.
like I've already talked about expensive car. For me, if more than 6 lakh, this is expensive one. So for more than 6 lakh car, I'll give 1, which is around 5 to 6. Around 5 to 6, I'll give them zero point 0.8. Around 3 to 4, I'm giving them 0.7. Okay, but all of them are included in the fuzzy set. Not like that. Below 6 lakh cars are not included in the fuzzy set. So fuzzy set is the generalization of our set theory. Is it okay? And this fuzzy set, it depends upon the membership function. Okay, and that membership function is defined from x to the closed interval 0, 1. Is it okay? As we know, the operation of classical set theory, union, intersection, all we know, complement we know. Is it okay? Now in fuzzy set also, we can define union, intersection, complement, all those things. Okay, here look at here. In that one, membership function is there. Membership function mu a car x, which is starting from x to 0, 1. That is called membership function. Like 0.8, 0.9, whatever we want to give for individual thing, that is our membership function. Like we can denote any fuzzy set in that way. X comma mu a curl x. Like 5 cars are there. First car, I'm giving you for first car. X means small x here. Small x means the first car. For first car, I am giving the membership function as 0.9. For second car, 2, I am giving the membership function as 1. For card 3, in place of x, we can put 3. That means third card, I can give the membership function as 0.4 in this way. So this is the collection of all this kind of pair, x comma mu a car x, where this mu a car x is the membership function. That means the value of mu a car x is start from 0, ends with 1, and we can take in between 0 and 1 also. Is it clear? The notation of fuzzy set. Like here, I am showing here one example. Like here, how many students are there? 5 students are there. And we assume that the set is smart student. A car is the collection of all the smart students. So G1, we first considered the G1, student 1, and we grade his or her smartness by 0.4. G2 by 0.5. G3 is extremely smart. He's smart, but not like G3. And G5 in this way. Up to this, any confusion of any student? Any student, any confusion up to this? How to write fuzzy set and all those things? And what is the difference between the fuzzy set? If we write down in set theory, only we can include G3. Only we can include G3 because G3 is the extreme smart. Other than this, we can't include. So, but here in fuzzy set, this is the generalization of our normal set theory. Okay. Now, one difference between fuzzy set and normal set is whenever we consider fuzzy set theory, the union of two fuzzy sets depends upon the membership function. Okay, maximum of the membership function. Whenever we consider the union of fuzzy set, then we take those elements whose membership function is maximum, and for intersection we take the membership function which is minimum. Now, there is a difference between in classical set theory and fuzzy set theory. The difference is what is the union of A union A complement in normal set theory? In normal set theory, what is the union of A union A complement? What is the answer of that one? A
Ma'am,
union A
five.
complement.
Union. U. Means union.
Universal set.
Yes, ma'am.
A union A complement is the universal set in our normal set theory, and A intersection A complement is 5 in our normal set theory. But look at here. Look at that example. In that example, here A curl is this one, G1.4, G2.5, G11, this one. Now, the complement of this one is, the complement of this fuzzy set is G1.6, G1.6, G2.5, G30, G4.1, G5.2. That is the complement of this fuzzy set. Actually, whenever you find out the complement of any fuzzy set, that means you have to uh, the membership function 1 minus this membership function. So the complement of this fuzzy set is G1.6, G2.5, G30, G4.1, G5.2. And whenever we take the union of the union of A, the set A and its complement, then it will not give you the whole set X or whole set U for fuzzy. For normal, A union E complement is always give you the universal set. But for fuzzy, A union A complement is always not will give you the whole set. Similarly, in normal set theory, A intersection A complement is 5. But in fuzzy, A intersection A complement is not always 5. That is the difference between the set theory, normal set theory, and fuzzy set theory. And one application of fuzzy set theory is our washing machine. Actually, in washing machine, always, if you see the washing machine, always these terms are there. Warm, hot, cold, all these terms are there. These are called linguistic variables. That means whenever we, our colloquial language, whenever we consider human language, then always that language is not precise one. That means this is not always like one or zero. We can always talk about in between one and zero. She is good, but not that much, and she is very good. Always we use this kind of term. Whenever we use this kind of term, that means these terms are fuzzy terms. Okay, washing machines are uh, washing machines are applying these terms: warm, hot, cold, and this will give us the crisp value after completion of the work. So, washing machine is the application of our fuzzy set theory. One of the application the fuzzy set theory has many applications. In engineering branch also we can apply fuzzy set theory. Up to this, any doubt from any student? What is fuzziness? Because I am going to the next one, another generalization form. That's why I'm asking that, is there any doubt in fuzzy set? So many things are there. Actually, I am telling about the preliminary things. What is the extension of preliminary? What is the extension of fuzzy set theory? Actually, like our matrices, we can study fuzzy matrices also. Everything is there in fuzzy. Like we in our classical set theory, with the help of this one, we can study the relation. With the help of fuzzy, we can also study the fuzzy relation. And with the help of set theory, we can study topology. Um, Similarly, with the help of fuzzy set theory, we can study fuzzy topology.
Fuzzy topology.
Shagurika, Shagurika, is there any doubt?
Yes, ma'am.
Yes, tell me.
Fuzzy topology.
Fuzzy topology. Do you know topology?
No, ma'am.
So, actually, this is you are the student of Shagurika,
11.
class 11. So, it will take some time to understand what is topology. Like, a topology, actually, topology is a Greek word. Hmm. Uh, Greek word in that topos, and this is the mixture of topos and logos. Okay, that means topos and logos means a discussion about the place. Discussion about the place where we are dealing with the discussion of the place, then we can study the topology. Like our Euclidean geometry. We have already know what is Euclidean geometry. In your class 9-10, you have gone through um, uh, um, the triangular property, that is similar triangle, then congruent triangle. The triangle is called congruent. Two triangles are called congruent when the two triangles are same in all respect. All respect means the shape, size, all of these things should be same in these two triangles. Then we can say the two triangles are congruent. If the shape and size and all other properties of these two triangles are same, then we can say that these two triangles are
Congruent.
congruent. Now, what is similar triangle? What is similar triangle, Shagorika?
Which are same.
Congruent means same. Only the difference between similar triangle means the shapes are same, size may differ. In similarity, whenever we consider similarity of two triangle, that means shapes of the triangles are same, but the size may differ. Okay.
Okay.
Similar to this, in topology, we can compare the two figures. Okay, I'm not going to the very much deep to topology because it will be very difficult for you to understand this one, because before study topology we have to understood what is real analysis. Okay, Shagorika. So
Okay,
it
ma'am.
will take some time to understood topology. Like our Euclidean geometry, topology is another kind of geometry where we can relate to shapes. Like our congruency, we can compare two triangles. With the help of similarity, we can compare two triangles. Similarly, with the help of topology, we can compare two shapes. Okay, the shapes may be different, but with the help of topology, we can compare the shape of two figures. Is it okay, Shagorika?
Yes, ma'am.
Okay, okay, thank you. Now, up to fuzzy, is there any doubt?
मैम थोड़ा
Hmm.
डाउट
Hmm. हाँ बोलो बोलो Shagorika, in which part? Tell me. Like in your class, Shagorika, I'm telling
यस
you the example of fuzzy. In your class, say 50 students are there. Okay, 50 students are there. For you have to decide those who are good in mathematics. Okay, you
ओके
have to find out the student those who are good in mathematics. Okay, 50
ओके
students are there. Okay, now first you choose 10 students. Those are very good in mathematics. Okay, 10
ओके
students are there. Those are very good in very good in mathematics. So give them membership function is 1. Okay,
वन ओके
1 for those students. Some students are there, those are not very good, like they are not getting 100 marks, but they will get 90, 90 marks. Out of 100, they will get 90. Okay,
ओके
so
मैम
you can give them membership function as 0.8. Is it okay?
यस मैम
Okay. Some students are there, those who are getting marks like 80, 80 to 90. You give them 0.7. In this way, you can uh, you can uh, separate all those students by giving some membership function. Do you understand my point?
यस मैम
So all of you are included in that fuzzy set by putting some membership function. And this membership function it depends on you because you are giving them the membership function. Is it okay?
यस मैम
But if we consider the classical set theory and if the question is write down the name of the student, those who are very good in mathematics, you have to wrote only those students, only 10 student name. Other than that, you can't write. Yes or no?
यस मैम
Do you understand my point?
यस मैम
आपको कौन से स्टूडेंट को लेना था जो बहुत अच्छे हैं मैथमेटिक्स में? You have
10
to only include them. Only 10 students. Other than that, then 10 students, no students are there in the classical.
ओके मैम
There, fuzzy set theory, you can include all the students of your class by giving them some membership function. Those who are very good, you can give them 1. Those who are getting marks from 90 to 80 to 90, 90 to 100, 80 to 90, giving them 0.8. Then 80 to 70 to 80, 0.7, like this. That means all of them are there. All of them are there. All of the students are there getting some membership. That's why fuzzy set theory is the generalization of crisp set theory. क्योंकि क्रिस्प में तो सिर्फ वो 10 लोग ही थे जो बहुत अच्छे थे मैथमेटिक्स में और फजी सेट में बाकी सब स्टूडेंट है 50 आउट ऑफ 50 स्टूडेंट्स आर देयर वो तो 10 स्टूडेंट भी है और बाकी सब भी है सो दिस इज द जनरलाइजेशन हमारा जो फजी सेट आया है वो बहुत बड़ा हो गया सेट क्योंकि here we can include all of them. Isn't it?
यस मैम
Okay. Now, in fuzzy, one difficulty is there. Difficulty means whenever, like, if good student for like Sagarika, for Sagarika, say good students, 10 students are good. For me, it can happen also 20 students are good for the same group. For me, 10 or 20 students are good. For Sagarika, only 10 students are good. So, the membership value depends upon the nature of the people. That means us, when we will decide what membership value you want to give. Is it okay?
Yes, ma'am.
It depends upon on us what membership value you want to give that the student, those who are good in mathematics. So this is the difficulty of fuzzy mathematics. After that, in 1999, Molotov introduced the concept of soft set. Hmm? I'm
Ma'am,
showing you here. Hmm.
third step, start
So, soft set,
soft set.
soft set. Wait 1 minute. I'll show one slide for that one. What is soft set theory? So, do you understand what is set theory? Set theory you already know. What is the preliminary difference between fuzzy set and normal set?
Yes, ma'am.
Srijit Gayen, you are the student of Srijit,
9.
class 9. Do you understand what I am trying to say, Srijit?
Yes, sir. I
Hmm?
mean, ma'am.
Okay, thank you. And Shai Lokesh Dasari, Shai Lokesh Dasari,
Yes, ma'am.
you are the student of?
EC branch, madam, from Agartala.
Okay. Do you understand what I'm trying to say?
Yes,
Shai
ma'am.
Lokesh, do you
Yes, ma'am.
understand what is fuzzy? Fuzzy?
Yes, ma'am. Okay, ma'am.
Okay, thank you. Actually, this is not the lecture, this is our interaction session. Ram Roshan, do you know what is fuzzy, Ram Roshan? I think you have already studied that one. Ram Roshan, am I audible, Ram Roshan?
Yes, ma'am.
Already you know what is fuzzy.
Yes, ma'am.
Am I correct?
Yes.
Whether I am able to see the give the hello, am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. Now I want to show another thing, that is soft set theory, which is the generalization of fuzzy set theory. So first we start from set, then fuzzy set, then soft set.
So,
Actually, soft, not hard. This is only soft. Hmm. Only soft, not hard. In mathematics, rough set is also there. Okay, set theory is there, fuzzy set theory is there, rough set theory is there, then soft set theory is there. Hard, soft सब है mathematics में. Okay. Now, uh, here I am showing you. First line is most of our traditional tools for formal modeling, reasoning, and computing are crisp, deterministic, and precise in character. But many complicated problems in economics, engineering, environmental science, social science, medical science involve data which are not always all crisp. we cannot always use the classical method because of various types of uncertainties, uncertainties presented in these problems. The important existing theory, that is theory of probability, theory of fuzzy set, theory of intuitionistic fuzzy set, theory of vague set, theory of interval mathematics, theory of rough set can be considered as a mathematical tools for dealing with uncertainties. Uncertainties means already I have discussed about the example of fuzzy set, very young, all these things are uncertain.
Hello.
Yes, Opurvo?
Hello.
Yes,
Ma'am, can I do one announcement?
yes, you can.
Yes, the people. I request everyone, those who have joined the meet, please fill the feedback form about this webinar. That you have what you have learned and about your experience about this session. Without filling the webinar, no one should leave the meet. Otherwise, the certificate of you will not be generated. For this purpose, TMA will be not responsible. So please, everyone, those who have joined from different parts, please fill the feedback form. I have sent the feedback form in the message section and confirm that you have filled that. Thank you, ma'am. You can, ma'am,
Okay,
start. Ma'am.
okay. Thank you, Apurva. Okay. Now, I'm not going to the various things. I'm showing you one example. It will be easier for you to understand what is soft set. Okay. Wait, I'm showing here. It will be easy or interesting for you to understand that one. Okay. Like here, look at it. Is it visible? I'm showing you here one page. Here, U. U contains how many elements? Six elements.
Six.
Hmm? Six. And these are the set of six televisions under consideration. That means we have considered six television set here. Is it clear? Now, soft set theory is dealing with several uncertainties, not only single uncertainty, not like that very good in mathematics. This is only one uncertain thing. Uh, Soft set theory dealing with various uncertainty. Is it okay? Like here, we have considered six television sets. Okay, and our parameters are denoted by capital A. What are the parameters?
Yes.
Parameters are, first parameter is costly. E1 is costly. Shagorika,
Yes,
please
ma'am.
you please mute your microphone. It will be easy for me also. Thank you very much. Look at here. E1 means E1 stands for costly. Okay, because out of these six television sets, some of them are very costly. Then E2 is cheaper. Then E3 is beautiful. E4 is brand 1 company. E5 is brand 2 company. E6 for style and E7 for customer service. These are the parameters. Whenever we go through for buying a TV or mobile, it is not like that you are considering only one parameter. When you deal with the mobile phone, first how many storage capacity is there? You first search this one. Whether it is stylish or not, you second go for that one. Then whether it is costly or not, you go for that one also. And whether the customer service is good or not, we always go for that one also, isn't it? So to buy anything, it will depend upon on several parameters. It will depend upon on several parameters. Here we consider only 7 parameters. And how many television set we have taken? 6 television set. So here F E1. E1 means which is costly. So the sets U1, U4 and U5 are costly sets. Is it okay? F E2 means you are considering those sets which is cheaper. Here U2 and U6 are cheaper. Now F of E3. E3 means stands for beautiful. Here U1, U4, U6 is U1, U3, U5 is go for beautiful. Similarly, E4 means brand 1 company, E5 means brand 2 company in this way. So, if our wish to, if my wish to buy a television which is cheaper but beautiful but brand 1 company, that means we want to take the intersection of E2, E3 and E4. So we have to find out those sets like F E1 contains how many, F E2 contains how many television sets. We want to take the intersection of those sets containing all these characteristics. Is it clear?
Ma'am, your voice is breaking, ma'am.
My voice is not coming
It's coming, ma'am, but it's breaking.
right now.
Hello.
Yes.
Okay, ma'am. Correct.
Okay. Wait 1 second. So, do you understand what is a subset? Subset is dealing with several uncertainty. Like I am showing here one example where the parameters are costly, cheaper, beautiful, brand 1 company, brand 2 company, stylish, and customer service. Wait 1 minute, it has gone. The network. Wait a second. Connection has gone. Is it visible? So here, whenever we consider FE1, FE1 means the sets. How many sets are there? Television says 6 sets are there. FE1 means we are considering those sets which are costly. We U1, U4, U5 are costly sets. FE2 means we are considering the cheaper set. Here U2 and U6 are cheaper sets. Then FE3 means the sets which are beautiful. Now, if my wish to find out the set which is cheaper, which is beautiful with brand 1 company, that means we go for with the intersection of E2, E3 and E4. If any set is there with the intersection of E2, E3 and E4, is there any set is there which is intersection of E2, E3, E4? Am I audible?
Yes, ma'am.
Any set is there which is the intersection of E2, E3 and E4, which is cheaper, beautiful and also brand one company. See the three FE2, FE3, FE4. Any set is common, but in between E3 and E4, one set is common. That means U1, which is beautiful and brand one company. But beautiful and brand one company means it should be costly. That's why it is belongs to E1. Is it clear? So
Yes, ma'am.
with the help of soft set theory, we can take decision which set is better. Is it clear? So it deals with several uncertainties, and with the help of this one, we can buy a mobile phone or TV or laptop or anything. That is the use of our subset theory, and which is introduced by Molotov. I am showing you the name Molotov in 1999. So I have already talked about set theory, then its extension of as a fuzzy set theory. Then the another extension is a soft set theory. In soft set theory is dealing with several uncertainties or several parameters. This is the generalization of our fuzzy set theory also. Uh, Up to this, any confusion or any question? If you have any question, please tell me. You can ask me any question regarding this. Okay, no doubt. So with this, I want to conclude my talk. Thank you very much once again for the organizer to give me a platform where I can share my thoughts with the students of class 9, 10, 11, like this. Thank you, Opurvo, to give me such a nice chance. Any other queries? If you have, then you can ask me. And if anyone is um, interested to study about mathematics, then you can go through for this fuzzy set, then rough set, soft set, all these things are there. Okay, thank you very much. Opurvo,
Yes, ma'am. I'm here only, ma'am.
okay. Thank you,
Thank you,
Opurvo.
ma'am. Thank you,
Hmm.
ma'am, for this wonderful information
Okay,
about set theory and the fuzzy set. And we also thank you for accepting our invite to join this meet and we got to know so many different things from you. Thank you for providing such a wonderful information. Thank you, ma'am, once
thank you,
again.
Opurvo.
Thank
Thank
you
you.
all the crew members of the Tripura Mathematical Association for actively participation in the group. Thank you all the recorder who have recorded the session from different part. All the recorder. I also thanks to all the recorder who have recorded the session. And also thank you to all the members who have participated in this session from beginning to the end and make this program successful. We also have tomorrow our last day 3 means day number 3. We have some new interactive means type of seminar, not like seminar, but this will be some interactive information or something like very much informative about Ramanujan's magic square. So all are requested to join tomorrow's at 11 a.m. sharp. Means you have to join by 10:40, and after that our event of webinar will be completed. Hello, Uday sir, are you there? Hello, hello, hello. The people who have filled the feedback form, please reply that whether you have filled the feedback form or not. Otherwise, you don't leave the group. Otherwise, the certificate will not be generated. After filling the feedback form, you can leave.
Apurva.
Yes, sir. Are you there, sir?
Yes.
Okay. So I request Uday sir to declare this day 2 of webinar closed. Hello.
Yes,
Hello.
Apurva. I can't. Something missed. You said once again.
I request Mr. Raghu Uday Kumar, PGT Mathematics Kendra Vidyalaya Panisagar to declare this 3-day National Mathematical Webinar day 2 closed.
Okay. I'm Uday Kumar of the Kendriya Vidyalaya Panisagar, PGT Mathematics. So, a very warm good morning to everyone. And it's a very great webinar conducted by the madam and all the participants who are participated very actively. So with this, we are concluding today's webinar. Thank you.
Thank you, sir. Thank you very much. The people who have joined